Hello and welcome to another video. Today we have a B450M Mortar Max from a viewer. Hi Dan, MSI B450M Mortar Max fails to boot after power supply failure. See if you can bring it back to life. Keep up the good work on the channel. James Taylor from the UK. Thank you very much for trusting me with your mainboard. And yeah, power supply failure. Really interesting. I don't really know what exactly happened to the power supply. I would expect now that we might have a short on one of the major rails on 12 volts, 5 volts, or 3.3 volts, and maybe the auxiliary 12 volts. And yeah, let's just see if we go from resistance reading, what we can read out from the 24-pin connector and see if anything is abnormal. So let's connect the ground. I often use the USB ports to ground my leads. And let's see now. We're going to be starting with, this is 12 volts, I think. This seems to have high resistance. There we go, kilo ohms. This is 5 volts, also kilo ohms. This is 5 VSB, also almost a kilo ohm, and 3.3 volts. Looks to be fine. Then let's go for 12 volts auxiliary at the CPU, which also has kilo ohms and rising. That looks good so far. Okay, let's go for some individual voltages. We have two inductors right here at the side, which are probably 5 volt dual and VDDQ, which means 1.2 volts for the DDR slots. So let's check both of these. These are through-hole inductors, which is why I need to raise the board up to check them. And we have kilo ohms and rising. And on the VDDQ, we have also almost kilo ohms. So that is fine. There's another inductor right here. This is probably the VPP, 2.5 volts for the memory. Also kilo ohms and rising. Now there are more small inductors that are a little bit harder to see, like this one. This is most of the time like a 12 volt input or something like that. Has also kilo ohms. Then there are more here. Kilo ohms. And another one here. And also high kilo ohms. That is very good. Let's go to the right here. There's another big inductor. This looks like it would be something for the PCH, where we would expect low resistance, like 23, no, 63. Oh, bad probing. 23. That is a little bit low, but it might be fine for the PCH. Let's see now. Let's go in a higher range again, and let's check this inductor, which is probably also a 12 volt one. Yep, looks fine. Then there are several MOSFETs often down here. For example, this is probably a 3.3 volt MOSFET or a linear voltage regulator, and that looks to be fine. The 3 VSB is most often located in between the PCIe slots here somewhere, and it's probably right here. Let's check that. Also has kilo ohms. So most of the inductors or the individual voltages look very fine from a resistance point of view. So I would probably go over to put power into this board and see how it behaves. Let's check the CMOS battery. Probably has been replaced recently. Yeah, a little bit over 3 volts, so that is fine. And yeah, that's pretty much it for what I would do as an initial checkup if I know that there has been a short or has been damage via the power supply, because so far there seems to be no damage, nothing obvious being shorted or anything. So we should be fine in putting power into this board. So let's connect our power supply. And for AM4, you always want a CPU already in here in order to test the board, because the CPU is part of a PCH, or the CPU has parts of the PCH that would normally be on the chipset for Intel boards. It has integrated into the CPU. So for startup procedure, to have the proper startup, you need a CPU in there. So let's now get the 12 volts running and let's have a look at the passive power consumption now. We would expect something around 100 milliamps to a maximum of like 130 milliamps. And yeah, if it's above that, there's probably something wrong with the standby voltage already. So let's fire it up and see. 200 milliamps, and it's rising. That is already a sign that there's probably something shorted within the 5 volt, 5 VSB line, because that is too high power consumption. So let's take off the mounting bracket so that we get better access to all of the components. And we are going to be using a thermal camera to see if anything already gets hot enough for us to notice it. So, got the thermal camera hooked up now. Let me remove the macro lens and let's first see like this. Let's go a little bit further into here. Let's supply power to here and let's see if we can find anything. And there is already something getting very hot. You could see this controller is getting very hot. That was very easy to spot because the difference is enormous. It's just that which is glowing hot and something there as well. So if I'm not mistaken, this is around the 3.3 volt regulation of this board. So let's go under the microscope and have a closer look at that regulator. What is happening with it, because we were checking the output of that, but it might be the chip itself that is just shorted. So let's turn on the microscope and have a closer look at it, because in this state you really don't want to power up the board or anything, or try anything, or have even the 5 VSB for a longer time added, because it's just going to lead to more damage. Because as you can see, that was 82 degrees on this controller right here already. So let's analyze this circuit a little bit without having a look at the schematic instantly, just to have a good look and see if we can understand what we have here. So what you can see, this chip, it has a ginormous trace here where this capacitor is. You can see this one. So this is either output or input, but it's probably input because this is the right side and then the left side is the MOSFET. And this is then probably the output. This is probably ground. This might be a feedback or something like that. This might also be a ground or a auxiliary voltage, another one. Or an enable something, a signal or something like that. But I would expect to either read a short now there, or there. So let's go into resistance reading once more. And let's see now if we get straight up 0 somewhere. So let's start right there. And no, we do not. Let's see. This is probably kilo ohms. So I would expect that this is like a 5 volt, maybe incoming. Yeah, 4.6 kilo ohms. And let's see now on this pin right here. And this is basically 0, if I can see this correctly. So this output pin has 4 ohms. This is probably our problem. Let's see right here. This one has 3 ohms. Okay, so I would guess that this is this ground? But this is not low enough for ground. Maybe my probes have bad contact. But at this point, I would just get a board view now. It's probably the component itself. The GS... What is it? Let's flip this a little bit and get a different view. GS7133. Pretty sure I've replaced one of these before. And yeah, there's also corrosion as far as it seems. I haven't noticed that before. Let me get tweezers. If you have a good look right at this capacitor, there's a lot of green around it. And also on the solder right here. It looks like it got a spill right here. Interesting to see that. Because this line is shorted also where this capacitor is. and this line is shorted. It might be the controller, but it might also be this capacitor. So let's go into board view and see what is responsible for what on this chip, which one is which of the pins. And to get a board view, we will need the model number. So many people search after this term right here, which is mostly correct, but for MSI boards in particular, you want this. This is their internal board number, MS7B89, with the 7, I don't know what the 7 is for, but afterwards is like the generation of boards. This is most of the time the important, and this is revision number 1.1. This sometimes is also important in order to know if there have been any changes to the PCB or not. So we're going to be looking for MS7B89. Now in our board view, let's see. We were looking at this controller, GS7133. So let's see, this pin. This is 5V dual incoming. Okay, this pin. This is ground. So this is supposed to be low resistance. And so this one isn't supposed to be low resistance. This is the 3VSB. So we were checking this input before, which is VCC3, which is the 3V auxiliary coming from the 24 pin right here. And the actual 3VSB is shorted. Now, the question is this chip shorted or something else shorted? My guess is that it's the chip, because this thing was getting very hot. It might be the output of it that is shorted. So something on this board, anything that you can see in yellow, could be short circuited via 3.3 volts and could be the reason why our controller got so hot, because it needs to pump out way too much current. So we have to determine now if it's the load side or if it's the actual controller that is shorted. And what we're going to do, we're going to be using voltage injection. We're going to be injecting probably just 1 volt for the beginning. It should be enough already. We might go up to 3 volts to see it better, but inputting 1 volt at any of these points really doesn't matter. All of the points where you can see the yellowing, we could even like use this TPM header and use that pin over there to inject voltage, to have an easier way to inject voltage somewhere. Because this pin, we might use that capacitor because it was quite big and that is easy to reach right there. So let me get it set up that we can do voltage injection and see through our thermal camera. So I now have the power supply connected on my tweezers. So there's 1 volt at the tip of my tweezers, and we're going to be using the thermal camera now. I will be injecting 1 volt right now. And there's almost 6 amp of power draw. But it doesn't seem to be the 3-volt regulator. Interesting. So I will have to zoom out more, and we will have to inspect the board. What exactly gets hot now? So, injecting it. Let me search for what is getting hot on this board then. Oh, right there. There's something heating up. Let's zoom down a little bit. It seems to be a electrolytic capacitor just. Could this be for real just a shorted cap? So I'm watching right there. Let me get the macro lens so we can see better. Right there. 50 degrees, and it seems to be just a capacitor that is shorted here. And if I now go, this was 1 volt, if I now go up to 3.3 volts to inject into that line, that should be glowing hot. Let's see now. Oh yeah, that instantly started smoking. Oh yeah. So let's have a closer look under the microscope there, on that point where that capacitor is. So it seems to be this little capacitor right there. And I don't really think that this thing has anything important to do. It really seems like just a filtering cap on the 3.3 volt line. Let's see in the board view what this is for. So in the board view, it is this capacitor right here. Yeah, this is just 3.3 volts to ground. This is nothing special that this one is providing. So we will do without this capacitor, pretty sure. So, what do I think? This capacitor is in a very difficult spot, because what you can see here is that there's the PCIe slot right next to it and two electrolytic capacitors. So taking it out is not easy. Let's not be lazy. I thought about just nicking it off there, just pulling it out, like just getting my tweezers into there and just breaking it off. But let's remove those two capacitors, do a little bit more work to do it properly. So I'm going to be taking a big tip onto my soldering iron, this one, to then flip the board around and desolder these two electrolytic capacitors in order for us to be able to take out the shorted cap better. So let's have a look. These are the two capacitors right now. And let's now get some flux onto them. Take some solder. Turn on our soldering iron. And what I do now, you've probably seen me do this before. You just go on both of these like this. Get a good amount of solder so both pads get wet. And then the capacitor is basically going to fall out if you catch both of them. Like that. And already the capacitor is out. Let's do it for this one as well. Just a good amount of solder. And now it's out. Now both of these are ready to be either wicked clean or with the solder sucker to be sucked clean. So if we now take some solder wick, let's try it with that. Even though solder wick is not really made for through-hole components, but it can work if you have a good amount of flux. Yeah, it doesn't work here. So now the capacitor is better exposed, that we need to take off. Let's now, because hot air won't be good here probably. Let's see if I can just take a soldering iron tip, apply solder to both sides and take it off like that. So what I want to do is to get this. The angle is really awkward because it is in between the PCIe slots, and getting there is really difficult. So let's apply solder to both sides here. And let's now try to bridge it, that we can get both sides wet, and then just remove it like that. Like that. Now the capacitor is out. And now let's take a resistance measurement at this place. Where is it? Right here. The top pad should be 3.3 volt and should not be shorted anymore. And the bottom pad is supposed to be ground. So let's see now. Let's get my multimeter. Let's get into resistance mode. Let's go for 20k. Let's see now. This should be basically 0 because this is... Oh, is it not? Is this the 3.3 volts? What is this then? This is ground. Okay, yeah, so the upper one is the ground one. I got them confused. And the bottom one is the 3.3 volt then. Okay, that seems to be high resistance now. And let's now check at our controller that we had before. It was this pin right here. And we seem to have high resistance now. There it is. Now we have 5 kilo ohms. That looks very good. Let's clean those places up a little bit. We really don't need that capacitor, but I know it's going to make some people angry. Let me tell you, if I wouldn't be doing YouTube, I would never replace this capacitor. Like, I do not care about that small filtering cap. It really doesn't make too much of a difference. And you can say, yeah, the engineers put it there, so there's a reason for it. Yeah, but there's so much overhead in the 3.3 VSB capacity, like, it's really not going to matter that much. But for the sake of the video, let me source a capacitor that is fitting for there, and let's place it there. So I have sourced a replacement capacitor. This is a 10 microfarad, 6.3 volts. So let's now place it properly right there. Get this side tagged onto here. And now this side. Let's add more solder to them. Some more solder right here on that side. And now the capacitor's in. A little bit awkward to solder there with the PCIe slot right next to there. But now it is in. Let's now try to clean out these holes right here that are still not open. Because I think I got 2 of them open, but not the other 2s. So let's see. This now is clear. This one is clear, but these 2 need still to be wicked out. Let me get some solder wick. I always dunk my solder wick in even more flux. There's already flux in this braid, but I just dip it into my flux to have more of it, because you can't have enough of flux basically. And yeah, it's just messier to clean up afterwards. I can see that. So let's now try to clean out these holes. So that seems to be clean. And this hole is mostly clean as well. Now trying to put our capacitors back into there wherever they have gone on my bench. Let's first clean this area up, because we won't be able to get to it anymore. So area is mostly cleaned up. A little bit left around that capacitor, but it's not too big of a problem. And let's see now. The capacitor have their marking on the negative side. So you can see the right side is marked plus and the left side is the negative. And the stripe on the capacitor means also the negative. So let's put it through there. Let's try to do the other one at the same time. Put the other capacitor in there. Now what I will do, I will hold them with my fingers, flip the board over, and I will try to solder them in. You probably won't be able to see this, but I'm just trying to hold them in straight and apply some solder to one of the legs, so it will be fixed in place. And when it's fixed into place, then I can properly solder them in. If they just have a little bit solder on either one of their legs, so that it cannot move anymore. So now they're just tagged on. Like, if you know welding, you know what tag welding is. They just have little bits of solder onto them, so they don't leave the place anymore. And what I do now, I now will properly solder them in. So properly heat up the hole and the pin and get solder onto there. Just like doing it on this one as well. Now that is also soldered in. It's really shiny because of the flux that I'm using. Very sorry for that, but they cannot get rid of the reflections here. Got that in, and also let's solder this one quickly in. And now we're fine. Now all of these are soldered in properly again. Always make sure to clean your solder tip afterwards, especially after using braid. Braid is really bad for solder tips most of the time. So yeah. And now getting all of that flux that we have used off of here will take some time, but we will manage. So now our area is clean, both capacitors are sorted in. And let's now see how the board will now behave. So I've now built the board up. And we have post LEDs right here. But let's see for the TPM header, where the post analyzer card is in. And let's have a look at the power consumption and see what this board now does. 120 milliamps. That is exactly like how I want to see it. Let's get a power button and a speaker also into here. So power button is on. Let's now turn it on. And I do not get any postcodes. Okay. But I do get postcodes on here. We have 2.2 amps of power consumption. Let's see now. Currently we have a stuck CPU LED as far as it seems. And we do not get any further than that. The CPU gets very hot. So vCore is definitely running. Interesting. But the board is definitely not posting so far. Let's get a different CPU into here. Don't know what kind of BIOS is on here. So let's try with a different CPU that might be supported on here. Let's check now. I also only get one postcode right here. Oh, I'm stuck on DRAM, it says on my DDR tester. Let me see. Let's replace the DRAM in a different slot and see if that can help. So pushing the power button again. Okay, DRAM tester says the same thing as before. Let's see if we have all of the DDR voltages. So let's get all of these out of here. Get only the DDR tester into here. Let's see if we have our DDR voltages all present. Because we might be missing VTT. And that's why we have no CPU initialization. So let's see. This is because of complaining RAM. But we have all of our DDR voltages. They are all present. Okay. We currently have a stuck CPU LED. And stuck CPU LEDs, most of the time in my experience, are either knocked off components or are a bad BIOS. Let me quickly have a look around the CPU socket if I can find anything like that. One moment, please. So, I couldn't find any knocked off components, but I have reset the BIOS now. Now I have taken out the CMOS battery and reset the BIOS, and let's see now. Now, okay, with this one, I'm not getting any postcodes. Okay, so it is because of the CPU that I'm using. Because have a look, as soon as I get this one out, and I put the 2600 in here, have a look now what happens. I now get postcodes. And these are also running now, the LEDs. But I now don't have a display. So let me turn it off once more. Because I will need a GPU in here. Because it doesn't have integrated graphics, the 2600. So let's grab a test GPU. Put this in here. Let's also populate the RAM. Just to try that also. Because it definitely wants to boot. And let's now see here. Have that. And let's now turn it on. So now postcodes are running. We have the GPU in. We now look at the current. This happened again. So let's see now, pressing the power button. Looking at the power consumption. Having 3 amps, going higher. You can see the LEDs turning off and on there. Right there. CPU. And should go out now. There it is. RAM training probably. 6 amps. With the GPU. And there's a post screen. Let's see now. Let's wait for the BIOS to actually pop up. Is it just my capture which doesn't want to work? Because probably is. Let me have a look at my display screen. Because we should be about booted now. Oh yeah, it's just, oh, there's just this, yeah, I see. There's this one line only there. Let's see now, if we reset, if we get into BIOS or something. So let me grab a screwdriver and reset this board. Let's see now if we can get into this BIOS. There it is. Now we can see something. It has seen all of the RAM, 20 gigs. Let's run the setup and get into the BIOS. Entering setup. And there it is. Now it's working. Let's now get into... Let's see, what kind of BIOS build date 21. So this is an old BIOS. Let's update this BIOS as well. Let's see if this BIOS can be updated. No, it doesn't seem like it can be updated internally. So via like having Ethernet, but the M flash is additionally. So let me get a flash drive and let's update this BIOS also. So I've gotten a flash drive prepared now. Let's enter the M flash mode right here, where the board restarts by itself. And let's update the BIOS, so this one is on the news and supports the news processors as well. So now we are in flash mode. Let's pick our file. And you can see the build date is from the 2024. You can see that. Let's see. Now you can see that. In the bottom right, there's 2024 instead of 2021. So let's update this BIOS here. And something very funny happened. My BIOS flash just failed. Very interesting. As you can see, the board now doesn't start anymore. It's stuck on a CPU LED. You can still see the screen where it actually failed. It failed from almost the beginning on. So yeah, have a failed BIOS flash. That sucks. Isn't really a big problem because there's an SPI header on this board. I will be able to flash quite quickly. But yeah, happens. It can happen, flashing the BIOS. It just turned off and turned instantly on again while the procedure, and now it's dead. What can you do? Things like that happen. But thank God we are properly equipped for solving this kind of situation. So let me do that. Let's get everything disconnected and use the SPI header on this to quickly flash the board. I won't show you this time, but let me quickly do that. So now the BIOS is flashed on this. Let's see now if it now works again. And if now I get something out of this 2200G, that it actually recognizes this APU. So, power consumption and turning it on. And it still doesn't want to see the APU. Interesting. Well then, it might just not be supported then. Might need a different APU. Let's see if the 3000G is supported on here. So 3000G in here. Let's see now. Yeah, this has different behavior. Let's see now. Will the CPU LED turn off at any point? Okay, this takes too long. Weirdly, both of these APUs are not supported by this board. Well done. Let's then take what we know is supported. Let's get this 2600 into here. And get a GPU into here again. And also put the battery back in here, so the BIOS isn't reset every time. There's already a NVMe in here, so we can go into Windows. Let's connect the Ethernet And let's hit this up now. And now we're posting again. Now I see post codes. Now the CPU LED should turn off every second now. There it is. Now it turns off and we should get a picture every second now. Well, one more restart because of new BIOS. Turn on by yourself, please. You should be turning on by yourself. Low. Okay, weird behavior. Resetting it by myself. And it turned off again. What is happening? Okay, now it turns on. Yeah, weird post behavior after flashing the BIOS. But now it does want to turn on. We have almost 7 amps. There it is, and there's the picture. And let's now see, do we go into Windows instantly? Does it want to load? Reset it again. And there's a screen that the BIOS has been reset. Let's load optimized defaults and just go with the Windows install that I have on here. And there's the logo. And now it's loading into Windows. That is very great to see. So, this board had a shorted capacitor on the 3 VSB line. We were very easily able to tell that because the passive power consumption was instantly rising as soon as we turned on the board. And then it was just getting to it and taking it out. And then we had a weird behavior of it turning off, doing a BIOS update, bricking the BIOS, and then we just had to flash the BIOS again on this. So nothing big here. And as you can see now, Windows is preparing devices because this is a Windows install that has been on many different devices. And yeah, let's now see that the Ethernet is also working and the audio is activated. And yeah, both is already running. That is very good to see. So that is it for the repair. Was a quite easy one. Really thankful for that. Still took quite some time, even though the diagnostic was very fast. But yeah, everything works, thank God. I will be sending you this back to the viewer. Hopefully he will have a good time with it and actually can put this board into use. And yeah, hope you enjoyed the video. Hope you learned something in this video. All of my tools are linked in the video description as always. This was Mainboard Medic. Thank you very much and goodbye.